What's up, everybody? In this video, we're going to cover USACO's 2020 February contest at the bronze level, problem 3, Swapity Swap. Farmer John's N cows, where N is between 1 and 100, are standing in a line. The ith cow from the left has label I for each 1 less than equal to I less than equal to N. So basically, you've got a bunch of cows. Here's a cow, standing in a line, and then they're just numbered 1, 2, 3, 4, and so forth, heading back in the line. Farmer John comes up with a new morning exercise routine for the cows. He tells them to repeat the following 2-step process exactly k times, where k is between 1 and 10 to the 9th. 10 to the 9th is a good number to kind of commit to memory. That's a big red flag. Even if you had a for loop that was just counting from 1 to 10 to the 9th and doing nothing in it, even an empty for loop, that's going to time out. 10 to the 9th is, you can't do anything to 10 to the 9th times and make it through the time constraints. So we'll come back to how to deal with that in a minute. The sequence of cows currently in positions A1 ... AN from the left reverse their order, where 1 is less than or equal to A1, which is less than A2, which is less than or equal to N. So essentially what that's saying is if I have my cows lined up, let's say I have cows lined up 1, 2, 3, 4, 5, 6, 7, for example. If A1 and A2, A1 was equal to, say, for example, 3, and A2 was equal to, say, for example, 5, then what that would mean is from cow A1 up to cow A2, which is indexes 3 through 5, they're going to reverse their order, which means the end result would be 1, 2, and then 5, 4, 3, which is reversed, and then 6, 7. Then the sequence of cows in positions B1 to B2 from the left reverse their order, where once again, same constraints. Both B1 and B2 have to be between 1 and N, and B1 has to be less than B2. So it's at least 2 cows. After the cows have repeated this process exactly k times, which we kind of hinted at we can't do this k times, so we'll have to find a way to make it more efficient. Please output the label of the ith cow from the left for each 1 less than equal to I less than equal to N. Test cases 2 and 3 satisfy k less than or equal to 100. 4 through 13 satisfy no additional constraints. If you try and just brute force this, you'll get the first 3 test cases, but 4 through 13 are all going to fail on a pure brute force. So we don't get a ton of time complexity issues in bronze problems, but this is a good example of one because of that 10 to the 9th. So what we're looking at is we're looking at coming up with a process where we can find a way to figure out where a cow is going to be after some number of moves without having to actually simulate all of the moves. And just as a real quick preview for how that's going to work, if I have, for example, 1, 2, 3 in that sequence, and then 3 reps back to 1. If I want to follow this sequence some number of times, for example, say like I would want to follow it 7 times, then starting from 1, I would go 1, 2, 3, 4, 5, 6, 7, and I would end on 2 by taking 7 steps. But you can very clearly see that every 3 steps, 1, 2, 3, puts me back where I started, which means if I were to subtract 3 from 7 and not actually do those steps, I could get down to 4. 4 steps is going to be the same exact result as 7. 1, 2, 3, 4 ends me on 2. And we can subtract as many 3s as we want. Minus 3 equals 1. 1 also ends on 2. So 7, 4, and 1 all get the same answer. The way you can get from 7 down to 1 quickly is by using division. Modulus is going to be your easiest tool for this. But if I have 7 moves that I need to make, and every 3 moves is going to put me in a full cycle, then I just divide those numbers. I have 2, which is going to give me 6, subtract 1, remainder 1. And then 1 is how many steps I need to make. In order to find this 1, there's 2 quick ways to do this. One is you can just do 7 modulus 3, which is the easy way. 7 modulus 3 would be equal to 1. The other way is you could do 7 divided by 3 and round it down, which would be equal to 2. Multiply it by 3 to get 6, and then do 7 minus 6, which would be equal to 1. Again, the modulus is probably the easier way to do it, but that's either way, that's what you're doing. You're trying to figure out how to get as many 3s out as possible so that what's left is the difference. So the next question then is how do we apply that to this question? Let's look at our sample input. So I've got 7 cows. I didn't read the input format. So the input comes from swap.in. So you have to make a file reader. The first line of the input contains N and K. So N, 7 means there's 7 cows. 1, 2, 3, 4, 5, 6, and 7. And then K is how many times you have to do the cycle. Here, we're only doing the cycle twice, which means we're going to do these 2 moves, and then we're going to do those 2 moves again. And again, this particular sample case would be very easy to brute force, but that's only going to get you through the first 3 cases. But this actually does give us enough information to figure out how to approach a more efficient solution. So if I were to swap 2 through 5, if I just manually were to make a for loop and go through these indexes and swap them with the opposite side, I'd have 1, 5, 4, 3, 2, 6, 7. The next one is 3 through 7. 1, 2, 3, 4, 5, 6, 7 right here. And I'll have 1, 5, and then 7, 6, 2, 3, 4. Now, what this gives me is this shows me where all the cows are going to go after these 2 swaps are done. I've got the starting positions of the cows, or rather, I've got what cows are in each position at the start, and I've got what cows are in each position at the end. So what that's really showing me is, okay, so for example, cow 5 started in position 5. After these 2 swaps, cow 5 is going to go to position 2. And anything in that position is going to go to position 2. So for example, if I were to do these 2 swaps again, right here, if I were to swap those, then I would have 1, 2, 6, 7, 5, 3, 4. And then if I were to swap the back half, I'm going to have 1, 2, 4, 3, 5, 7, 6. So the thing in position 5 went to here. 2 used to be 2 is now in position 5, and after the second repeat, 2 is going to end up in that position. That's going to happen each time with every number. You can see, for example, 6 was here, ended up in this position. Position looks like position 4, which means 3 now is going to end up in position 4 after the next time you do it. So we can use the fact that we know this pattern, and then we have to do, this is like 1 time, this is 2 times. So this would be the final answer here, 1, 2, 4, 3, 5, 7, 6, 1, 2, 4, 3, 5, 7, 6. But we need a smarter way to do this because we don't have the ability to do this in brute force. I would recommend fiddling around with this a little bit with a pencil if you haven't already, and then we'll go ahead and do this on all the way out, and I'll run through the full algorithm. I'm going to write down this sample data: 7, 2, 2, 5, 3, 7. 2, 3, 4, 5, 6, and 7. Okay, so we're going to run through the full algorithm. There's really just one major optimization we have to figure out how to do, which is how to make that k value smaller. Because if I have a k value that's equal to 10 to the 9th, I can't do anything 10 to the 9th times. So I need to find a way to reduce that number by using division. And then the key is, what do I divide that by? That's going to differ for each cow because each cow is going to take a different number of moves to get back to their own starting position. So let's walk through the swap once. So if I swap cows 2 through 5, that's going to be these. I'll have 1, 5, 4, 3, 2, 6, 7. And then I have the 3, 7 swap, which is here to here. That'll give me 1, 5, 7, 6, 2, 3, 4. Now I don't really need this middle step, so I'm going to go ahead and erase it. What this has given me right here, this number set right here, this is telling me what cow is in each position. So if I have, this is the cow number, then this is the position. Then this works kind of like an array. This is position 1, 2, 3, 4, 5, 6, and 7. Then I can see that cow 1 is in position 1. I can see cow 5 is in position 2. Cow 7 is in position 3, and so forth. Now, what I actually need to do is I need to invert the indexes and the values. And here's why. If I look at this, if you treat this like an array where the bottom, the position is the index and the cow is the value in the array. If I were to look at that, then I say I have an array of integers, which goes 1, 5, 7, 6, 2, 3, 4. But if I were to go back and say, okay, for the cow in position 6, where did they end up? I have to manually search through here and locate the 6 to know where they ended up. But if I could invert the values and the indexes, for example, if I were to have my indexes be cows, cow 1, cow 2, cow 3, cow 4, 5, 6, and 7, and then my value be the position where that cow ends up after one turn, then that would be a lot more useful for me for doing a quick lookup. So what I can do is I can loop through this, and for each one of these entries, I'm going to take the cow as if it's the index, and then I'm going to write the index in as the value of that cow for that position. Let's go ahead and walk through that and see what that looks like. So cow 1 is in position 1, no change there. Cow 5 is in position 2, which means what I'm going to do is go to index 5, and I'm going to put a 2 there. So then later, if I were to do this array down here, square bracket 5, that'll tell me where the cow in position 5 is going to end up after the next cycle. The cow in position 5 is going to end up in position 2. Same thing here. I've got 7, 3, so I go to index 7. I put the 3, which is the index value. I've got 6 and 4. Index 6 gets a 4. Index 2 gets a 5. Index 3 gets a 6. And index 4 gets a 7. Now, this array now is significantly more useful to me, because what I can do now is if I want to know where all my cows end up, I can take my initial cow as the index and find the final position. Let's go ahead and wipe out all this data just to demonstrate how that works. Okay, so what I can do now is for each one of these cows, position 1, I go to index 1, I see that cow ends up in position 1. So cow 1 will be in position 1. Cow 2, I go look that up, cow 2 will be in position 5. And I can look each of these cows up. Once I've done that, I'll manually do the swap, and then we'll show how those correlate. So once again, 2 through 5 are going to swap, 1, 5, 4, 3, 2, 6, 7. Then positions 3 through 7 are going to swap, 1, 5, 7, 6, 2, 3, 4. If I were to then check and say, okay, this is after the first swap, let's actually go ahead and do it 2 more times. We're going to do the 2 swaps. So I'm going to have 1, 2, 6, 7, 5, 3, 4. And the back half, 1, 2, 4, 3, 5, 7, 6. Okay, so if I want to be able to skip from here to here or skip from here to here, let's actually use our chart down here to see how that works. So this cow right here, cow 4, I want to know where cow 4 is going to end up. I go into index 4. I see that cow 4, the cow that starts in position 4 is going to end up in position 7. So my expectation is that cow 4 is going to go to position 7. And here we are in index 7 with cow 4. Now I want to know where that cow is going to go next. The cow is currently, despite the fact that it's cow number 4, is in index 7. So I go to index 7. I see that the cow in index 7 should go to index 3. And that is, in fact, where cow 4 went. Cow 4 went to index 3. I could then figure out very quickly, where's the cow going to go next? The cow's in index 3 right now. So I look in index 3. That means that cow, after another 2 swaps, is going to be in index 6. And then after going to index 6, that cow is going to go to index 4. Feel free to use pencil paper and trace the next 2 swaps out if you want to confirm that. But because what's happened here is I've gotten a chart down at the bottom that shows me, given a position of a cow, where's that cow going to be after 2 swaps, which means I don't have to do those 2 swaps. I just need to look at what the end result is going to be of those 2 swaps for a cow that started in that position. And that's the case for all these cows. Cow 6, the cow in position 6 goes to index 4, and then there it is in index 4. And now it's in index 4. The cow in index 4 is going to go to index 7, and there it is in index 7. Okay, so this is the first step, is to get this chart generated at the bottom. And just as a quick reminder for how we did that, we started with the cows just as an array or a vector, 1 through n, and we just manually did the swaps. You can do those with a for loop. That's fairly simple to do. Essentially, when you have to swap numbers, if I have like 1, 2, 3, 4, 5, 6, 7, if I want to swap 2 through 5, what I need to do is figure out how many cows I'm going to swap. In this case, I'm swapping 4 cows. So since I'm swapping 4 cows, there need to be 2 swaps done, which is 4 divided by 2 equals 2. And then I can start a for loop here and just go 2 steps this way. And if this is my left side and this is my right side, then I know the item when I is 0, I'm swapping the item that's 1 step from the left with the item that's, or 0 steps from the left with the item that's 0 steps from the right. When I is 1, I'm going 1 step from the left to get to the 3. I'm going to swap the item that's 1 step from the right to get the 4. And you can just do that with the 2-part swap with a temp. So temp equals L plus I, and then L plus I equals R minus I, and then R minus I equals temp. And that'll be your swap. Okay, so we have this this chart built. So then what I'm going to do is I'm going to say, okay, so now that I have this chart built, then for each one of these cows, I want to figure out how many steps it's going to take before that cow goes in a cycle. So once again, having my cows, once again, some sort of a for loop. For every cow, for example, for cow 1, I want to know how many steps, how many times do I have to look it up in this index before I go in a full loop. One way you could do that is you could just set current equal to I. So if I have for from, you know, position 1 up to position 7, or if you zero index, however you choose to do that. We're going to take the current position, the steps to make a cycle is going to start at 1, because it's always at least 1 step. And the current position is going to be equal to, if we called this our destination array or vector, whatever, would be equal to destination of I. So after 1 step, then my current position is going to be wherever I'll go after I. So for example, in the case of cow4, after a single step would be in position 7, which would mean steps would be 1 and current would be 7, because that's where cow4 would be after 1 step. In the case of cow1 never moves. So with 1 step, the current position would be the destination I, which would just be 1. Once we've got that, we essentially want to do while I is not equal to the current position. Basically, while it's not in its current position, we want to count the steps, plus, and then set the current equal to the destination of the current. We'll keep updating that. What that's going to do is that's going to get us out of this loop for each cow. After we get out of our while loop, we'll know how many times that cow has to move in order to get back to their starting location. And from there, it's just like, I mean, it's just eeny, meeny, miny, mo at that point. Give me a sec, let me demonstrate that. So let's look at let's look at cow 4. So cow 4. So if I start with cow 4 and I say, okay, cow 4. So after 1 step, that's going to put cow 4 in position 7. That's the current, because that's what's in index 4. Then our while loop loops around after 2 steps. Then we're going to be, for position 7 is going to take us to position 3. After 3 steps, our position is going to go from 3 to 6. And after 4 steps, our position is going to go from 6 back to 4. So that's a loop. I've got 4 steps to start at 4 and to end at 4. Just by coincidence, it happened to be 4. So what's going to happen with 4 is going to go to position 7, then position 3, then position 6, and then back to position 4. And you know that's going to take 4 steps. Since you now know that that's going to take 4 steps to do, what you can do is whatever your k value is, you do k modulus 4 or whatever that number happens to be, which will equal something. So say, for example, like it's 11. Then what's going to happen is I'm going to do k modulus 4, I'm going to get 3. And then I've already got 4 in its current position. I just got to do it 3 more times. So I do a for loop. I look up where 4 is going to be again. 4 is going to be in 7. Second step, the cow from 7 is going to be in 3. Third step, the cow from 3 is going to be 6. That tells me that cow 4 is going to be in position 6. So if I wanted to have my final positions, then I would go to index 4, 2, 3, 4, 1, 2, 3, 4, and I would put a 6 there. And that'll show that cow 4 ends in position 6. Let's go ahead and do this for all the cows. I'm going to go ahead and clean this up here. Again, we'll run all the cows, and then I'll cut you guys loose to code this. Okay. Okay. So for each cow, starting from cow 1, we're going to see first how many steps does it take to go in a loop. So with 1 step, cow 1's back to 1. That's done after 1 step. With cow 2 is going to go to position 5. The cow in position 5 is going to go back to 2. So that's 2 steps to go in a loop. Cow position 3 is going to go to 6. From 6, we'll go to 4. From 4, she'll go to 7. And from 7, back to 3. It's a 4-step process. For 4 is going to go to 7, which then goes to 3, which then goes to 6, which then goes back to 4. 5 goes to 2, and then back to 5. You notice, by the way, that 5 and the 2 are in a group. If 2 goes from 2 to 5 to 2, then it stands to reason that 5 can only go from 5 to 2 to 5. There's no way for 5 to go to a different position. Otherwise, 2 also would have found that position. There's a silver version of this problem. This is actually a really important concept for that, because that needs a further optimization that hinges on that idea of how big these groups are. For 6, we go from 6 to 4, and then to 7, and then to 3, and back to 6. And finally, cow 7 is going to go to 3, and then to 6, and then to 4, and then back to 7. Having now completed this, for each one of these cows, and you can do these on a 1-by-1 basis, you don't have to store all these. For each of these cows, as we solve it, once we've solved it, we want to figure out what the k modulus, however many steps it was, we want to put that into an array. So 6, 7, 1, 2, 3, 4, 5, 6, 7. Yeah. Okay. So for this example, we had a k value of 2. A k value of 2 equals 2. So what's going to happen then is for each of these steps, we're going to get the k value modulus the number of steps, and that's going to tell us what index we end on. So for 1, we've got 1 step to do a cycle. So k modulus 1 is going to be 0. So we do index 0. That shows that cow 1 is going to be on index 1 after 2 steps. Cow 2 is 2 steps. So k modulus 2 is 2 modulus 2, once again 0. Hang on. 2 modulus 2. Yeah, once again 0. So actually, I need to go off of the. I need to treat this like it's index 0. The starting location is index 0, not the ending location. Just real quick update that so I don't confuse myself. Okay. So yeah, so 1 went to 1, so that's index 0. For 2 takes 2 steps to go in a cycle. So with a k value of 2, 2 modulus 2 is going to be 0. Index 0 is going to be 2. That shows me that after 2 steps, cow 2 will be in 2 position. For cow 3 is 4 steps to go in a cycle. So if I do k modulus 4, it'll be 2 modulus 4, which is going to be 2. That tells me I got to go to index 2, which is 4. The 4 here then shows me that cow 3 is going to end up in position 4. And remember, this is the position, this is the cow. And then the same is going to happen for cows 4 and 6, actually. For cow 4, it's 2 steps modulus 4, because it's 4 steps to go in a cycle. So index 2 is going to be 3. I'm going to put the 3 here. And then I'm overlapping my video. Let me see here. We've got position and cow. I'm going to copy this down real quick. 1, 2, 4, 3, blank, 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 cow. 1, 2, 3, 4, 5, 6, 7. Okay. Let's see. Cow 5. So cow 5. K modulus 2, there's 2 steps to go in a cycle. So 2 modulus 2 is 0. Index 0 is 5. So put the 5 there. Cow 6, 4 steps to go in a cycle. So with a K2, we do 2 modulus 4, and that'll give us index 2. And remember, this will work for any K value. So if K was like 777, then we just do 777 modulus 4. And whatever we get from that, that would be our index that we'd have to go to. And then it would just be that index out of this cycle, 6, 4, 7, 3. If you don't have these stored in a list, which you probably won't, you can just do a for loop using your destination thing, however many times it is. So for example, if I have k equals 2 and I do modulus 4 and I have a remainder of 2, then I can just do a for loop for I from 0 to 2, and then just do current equals destination of current, or whatever. And then that's going to take me that many steps, and then whatever current ends at, that's where that cow ends up. So that's basically what we're doing is for each of these cows, cow 6, I found out that after doing it 4 times, I went in a cycle. I do k modulus 4, giving me 2. I then do it 2 more times, do a for loop again and go 2 more steps. And that'll put me at 7, shows me that 6 is going to end at 7. Then cow 7, once again, k modulus 4 is going to be 2. So we get index 2, that's 6. That shows me this cow's in position 6. Now, final step in order to be able to produce this answer. We can now see where each of the cows are going to end up, but the output that they're asking us is not where each cow ends up, it's what cow is in each position. So just like we did in the beginning, we have to invert this with a for loop. So have like some sort of a final variable, index 1, 2, 3, 4, 5, 6, and 7. And we're basically going to run through and use the value as the index because we want this to be the cow, and then we want this to be the position. So what cow is in position 1, what cow is in position 2. So as we loop through, we use 1 as the index and write 1 to the value. Use 2 as the index, write 2 to the value. Use 4 as the index and put 3 as the value. Use 3 as the index, put 4 as the value. 5 is the index, 5 is the value. It's the same as in the beginning, as we have like final at my result of I equals I. This is if I was going to call this result, then final result at I equals I. For index 7, I put a 6, and then for index 6, I put a 7. You know, and again, in each one of these, the top is going to be the index, the bottom is going to be the value. And what I have for that is 1, 2, 4, 3, 5, 7, 6. We check back on this. You'll see underneath this big scribbly mess, 1, 2, 4, 3, 5, 7, 6. So just as a real quick recap, write all your cows out, 1, 2, 3, 4, 5, 6, 7. Manually do the swap. So the for loop, swap 2 through 5, 1, 5, 4, 3, 2, 6, 7. And then for 3, 7, these guys, 1, 5, 7, 6, 2, 3, 4. Treat this like the index and your index as your value. Make an inverted version of this. So 1, 2, 3, 4, 5, 6, 7. 1 takes 1, 2 goes in 5, and 5 goes in 2, 5 and 2. The 3 goes in index 7, so 7 takes a 3. 6 is going to take a 4. 3 is going to take the 6, and then 4 takes the 7. Once you've inverted the indexes and the values, you then go through each cow. We'll just demonstrate one of the cows. I'll do cow 6. Pick one of the cows, for example, 6. Count how many steps it takes them to go in a cycle. So 6 is going to go to 4 because index 6 has a 4. Index 4 goes to 7. Index 7 goes to 3. Index 3 goes back to 6, showing that we have 4 steps. Once we figure out how many steps it is, we take k, modulus that number of steps, whatever k happens to be, and we get our result, in this case 2. Repeat that with another for loop, go 2 more steps. So once again from 6, we go to 4. Once again from 4, we go to 7. 7 is going to be the ending location. You write down all those indexes, where you have the cow number, and then its position will be the value. So cow 1, 2, 3, 4, 5, 6, 7 in an array, and then all those positions. So we found cow 6 ends in position 7, and so forth. And then finally going through this one more time and inverting it one more time into a new array where the position is going to be the index, and then the value will be the cow number. And then we just use whatever our position is as our index, and whatever the index is becomes the value we place there. And then we just need to print out that array. Alrighty, that's the problem. Good luck coding it, and I will talk to you on the next one.